Good morning, all of you. So, as we know, till now in the chapter, we studied what is work. So, work, when it is horizontally, the work is done. The force is applied on any kind of body, and the object is displacing in the same direction horizontally. So, as we know, what is the formula, guys? What is the work done formula? Work done W is equals to respond force into displacement. Yes or no? That is what it is. Next, if we are doing against to gravity, then the work done is equals to we have been done. So yeah, the work done W is equals to, in place of F, what we can write? Everybody, in place of F,
Mass
from the Newton's second law, F is equals to mass into acceleration due to gravity. So I will write M into G, and when we are throwing up, going against to gravity, distance we will consider as something. What is that, anybody? It is considered as H. So H we will say. So MGH. So that is what you all need to remember. Both are same only. So work done is equals to force into displacement, or work done is equals to MGH. This is working against to gravity, means vertically, and this is horizontally. So what is the SI unit of work done, everybody? What is the SI unit of work done? Work or work done? Everyone. SI unit of work done is equals to, everybody, joules. Okay. Now joules, and we know 1 joule is equals to how much, everybody? 1 joule is equals to 1 Newton into 1 meter. So that is what we used to call as 1 joule. I told you another formula. Of course, from this one, 1 joule is equals to, I will say, 1 joule is equals to 1 Newton into 1 meter. But what about from this? So can anybody tell me one more formula of 1 joule? Mr. Harish, Nimish, 1 joule is equals to what? Mass. Yeah, mass. What is the unit of mass? Everybody. What is the unit of mass? Kilogram. What is the unit of acceleration due to gravity? Meter per second square into, what is the unit of height?
kg meter square per second square.
What is the unit of height? Meter. So I will write this one as kilogram meter square per second square. Yes or no, Mr. Omar? Agilan? That is what you have to remember it along. So now I am saying you once again, all of you remember 1 Newton. This is the most important in numericals. 1 Newton is equals to kilogram meter per second square. Is it right or wrong, everybody? Yes or no? All of you? Because F is equals to mass into acceleration. So this formula will come. Now, work done is equals to, all of you remember, force into displacement. So in place of force, I can write this one. So what is the formula? 1 joule is equals to, everybody should open your mouth, kilogram meter square per second square. Have you noticed the difference, everybody? Yes. So that is the most important thing which you need to remember, because when we are converting the units, you have to remember this. Next, we have been done the relation for kinetic energy. Of course, energy first. So what do you mean by energy? Definition, Harini. Good morning, Harini. Please respond and say the definition. Yesterday's class also I told you. Third day I am saying the same definition. Anyone? What is the unit of energy? Sorry, definition of energy. All of you.
capacity of a body to do any work.
Yes. A capacity or ability of a body to do work. We used to called as energy. So what is the SI unit of energy? Anybody? What is the SI unit of energy? Joules only. But here, is it possible to write Newton meter in place of joules? Can I write Newton meter in the case of energy?
Yes.
No.
Yes, sir.
Yes, sir. Understanding? In energy, we will write only joules. But in the case of work done, in place of joules, we can write also Newton meter. Understand, Mr. Harisaras? Be very careful. Okay. So that is what you have to remember. So what is the CJ's unit of energy? Everybody? What is CJ's unit of energy? Ergs.
Erg.
So 1 joule is equals to how many erg? Anyone?
10 power 7 erg, sir.
10 power 7 or 5 Hari?
7 right, sir.
10 power 7. So 10 power 7 ergs. So that is you have to remember. So 1 joule is equals to 10 power 7 ergs. Now, let us comes to here. These energy we will classify so many types: light energy, heat energy, sound energy, mechanical energy. So mechanical energy means two things. What is mechanical energy, everybody? Mechanical energy is the addition of two energies. What is that energy? Mechanical energy means everyone.
Kinetic and potential.
Yes. Kinetic energy plus what energy?
Potential energy.
Potential energy. So that is what you have to remember that. So all of you should remember energy is so many types: sound, light, wind, tidal. Okay. What is that? Nucleus energy. So lot of types of energy is there. But in class 9th only we will focus on two types of energies. So in that the most important energy is kinetic energy, which we are presently studying. So after that, we will study what is potential energy. So now coming to the kinetic energy. So kinetic energy is causing due to the what, guys? By virtue of its motion or position. Anybody? Kinetic energy is causing due to its what?
Motion.
By virtue of its motion. So which object will produce kinetic energy? The body which is in state of rest or state of motion? All of you.
State of motion.
State of motion. All of you must remember that the body which is in motion will possess what energy? Everybody will possess us. All of you
Kinetic energy.
will possess
Kinetic energy.
kinetic energy. That is the basic thing which you all need to remember. So kinetic energy is possessed by due to its motion. So any object, if it is in motion, motion means either horizontally or vertically, doesn't matter. So always, if it is in motion, it will possess what energy? Everybody, it will be kinetic energy. Okay, and we all need to know the derivation formula for kinetic energy. So what is the formula for kinetic energy? Mr. Kaushik will. Mr. Kaushik, formula for kinetic energy. Speak, open your mouth. Mr. Aswin Balaji, you also should need to say. Otherwise, I won't entertain that. So kinetic energy, I want the response from you all people. So kinetic energy is equals to, as we know. First of all, you must tell me, what is the relationship between work done and energy? Anybody? Work done and energy. Mitaksri? Yes, please. Energy possessed by the body, which is equals to what? Energy possessed or energy released by the body, which is equals to what?
Work done, sir. Amount of work done.
Amount of what? Work done.
Work done, sir.
Yes or no? That is what. So if my body is releasing 100 joules of energy, so that how much work done I can do? Everybody, I can do
100 joules of work done.
one joule. 100 joules, 100 joules. That is what you have to remember it, all of you. So always energy possessed by my body, which is equals to amount of work done. So with the help of that, we have solved kinetic energy formula. Can you tell me, everybody, what is the formula for kinetic energy? Half.
1/2 into mass mv square.
You must say half mv square. What is the formula for kinetic energy? Half mv square. Okay. Now we will consider half is a constant. We'll forget about it. Now, last class, yesterday's class, what we studied, two things we studied. That is what? Relationship between kinetic energy and mass, and same way relationship between kinetic energy and velocity. So yesterday's class is most important class. You all should, those who are missing, everybody need to watch the class once again without fail. Okay. Now let us observe very carefully. What is the relationship between kinetic energy and mass? Everybody, Omar, kinetic
Directly proportional.
is proportional to mass. Understanding? If mass become double, then kinetic energy also become what? Everybody,
Double, sir.
Double, sir.
kinetic energy also become double. Are you clear, all of you? Understanding? If mass become m by 2, then kinetic energy also become what?
Half, sir.
Kinetic energy also become half. Are you clear? Danishkar, Arun Kailash, Akilan, both are directly proportional to each other. If one increases, another one also increases. Understanding? If one decreases, another one also decreases. Anything doubt, guys, in this? Akilan,
No, sir.
Gopal, that is. So most important one, you all should need to know this one. Please kindly learn it. Any doubt, ask. Next, second relation. Kinetic energy is directly
Is directly proportional to the square of the velocity.
square, directly proportional to velocity square. So if velocity become, understanding, v become 2v, v become 2v, then kinetic energy becomes how many times, guys? All of you? 4
Four times.
times it increases. Please note it down. Next, if velocity become v by 2, velocity is reduced to half, then what about the kinetic energy? Fastly, everybody. Kinetic
V by
energy
four.
is increased by what?
1 by 4.
Kinetic energy is
V by 4, sir.
by 4 times. That is what you have to remember it. Is it okay, everybody? Mr. Noor, Mr. Sanjay. So that is what in yesterday's class we all solved. Everybody need to know till here. Anyone having doubt, please kindly ask. Clear, Akilan? Arun? Mr. Daniskar? That is what. Now, today's class, I'm going to say you the most important one. That is what? Work energy theorem. So this is the most important one while you are calculating the numericals. So most of them they don't know, but you all should need to learn. It's very simple one, but we'll derive it in our today's class. So please, all of you keep writing. Work energy theorem. Harini, are you writing the notes? I want the response. Mr. Johan, you also. Everyone should write the notes. Work energy theorem. Kaushik, even though I will say also you won't open your mouth, correct? Work energy theorem. So please write it. So observe very carefully. What do you mean by kinetic energy? When it will process kinetic energy, when it is in motion or when it is in rest? Anybody?
Motion. Motion.
No. When it is motion. For example, when I'm in running, I am producing a kinetic energy which is equals to 10 joules. Means what is the work done by me, guys? Anybody? What is the work
10
done?
joules, sir.
10 joules.
10 joules.
Is it yes or no? Please respond.
Yes, sir.
So that is only work energy theorem. What work energy theorem means? This will be states that this work energy theorem states that, understanding, total work done by the body. Please write total work done on a body is equal to the change in its kinetic energy. Change in its kinetic energy. So that is only the work. What is work energy theorem? So the total work done on a body which is equals to change in kinetic energy. That is what you have to remember. What is work energy theorem? So now, if you understand this, then I will proceed further and I will explain it slowly so that you will understand it very clearly. Shall we proceed now, everybody? Again,
Yes, sir.
make some assumptions. If a body is initially moving with some, before see, when we are deriving the kinetic energy formula, we consider initial velocity of the body. Check your notebooks and tell me, initial velocity of the body is what? 0 or it is already having something. Anybody?
0, sir.
Consider as 0. Now, for work energy theorem, we will say body is already moving with some velocity. Now, it will attain some other velocity after certain distance. So that, what is the initial velocity? Anybody? Is it 0 or not 0? Anyone? I want the response.
0.
Not
No, not zero. Understand, Harish? Harish, there
Yes,
are-
sir, not zero.
I'm considering that already it is moving some velocity. Do you understand it? If a body, be very careful. If a body is initially moving some velocity, means initial velocity is zero or not? Everybody, Nimish? Initially, a body is initially moving with a velocity V, sorry, velocity U. Is it initial velocity zero or not? That is what my question. Already moving. Is it
No,
zero?
sir.
No,
No, sir.
not zero. Understanding? And attains a velocity. All of you try to answer, then only it will be good. If you are involving in class, only it will be nice. Attains a velocity after traveling certain distance. So can you tell me what is that velocity symbol? After certain time, it is attains a velocity. What is the symbol will take?
V,
V.
sir.
After traveling some distance. Have you noticed it? I am never considering time. So always you should remember which equation of motion we will use. I never talk about the time. So which equation?
Third equation, sir.
Third equation, sir.
Understanding? Traveling a distance. Actually, this is the most important one. So what is the distance symbol, everybody? Distance symbol? Yes. Understanding? By the application of force. By the application of force. So what is the symbol of force? Everyone? Force F. Okay. Then from the Newton's second law, can you tell me what is the force is equals to from the Newton's second law? From the Newton's second law,
Mass into acceleration.
yes. From the Newton's second law, all of you should say that F is equals to what? Mass into acceleration. Let me take this is equation number 1. So according to the assumption, can you draw the diagram, everybody? Can you draw the diagram? This is the body. Is the body initial velocity zero or not zero? Already body is having some initial velocity. Do you understand, everybody? It is not a zero.
Yes, sir.
Okay. Now, I suddenly, for example, you are riding a bicycle. Suddenly, your sister or brother will come and will push you, so that your velocity will change or not. Everybody, suddenly I am applying the force on you people, so that you attain say some more velocity after traveling some distance. So that distance only what we are consuming, what we are assuming, the distance we are assuming as all of you. Distance we are assuming as a what? Yes.
Yes, meter.
After traveling certain distance, what is your velocity?
V,
What is
sir.
your velocity? V. Okay, Mitakshri, Abhirami, clear? Arun,
Yes, sir.
that is. Now, observe
Sir,
very
can you explain again?
Omar, nothing, Omar. For example, see, Omar, you are riding a bicycle, Omar. Are you clear, Omar?
Okay, sir.
Now, what will happen means, now you are traveling with some velocity. Your velocity is initial velocity is 10 meter per second. Let me take. You are not in a zero, Omar. Already you are traveling. Now, I will come and I will apply the force. I will push you from the backside, so that your velocity definitely will increase or not.
Yes, sir.
It will change in velocity. Decrease or increase doesn't matter. Your velocity will change or not.
Yes, sir.
So initial velocity I am not considering as a zero. And due to applying force, your final velocity will become V. So that is what I am assuming to solve the work energy theorem. Are you understand, Omar?
Okay, sir.
Here, Omar, I am not considering
Yes.
kinetic energy derivation. We consider initially body is at rest or not. Kinetic energy derivation.
We
Initially
will consider, sir.
rest, due to applying force, body attaining some velocity. Yes or no?
Yes, sir.
So initial velocity is zero there. But here, already body is having some initial velocity, and due to the applied force, it is attaining some other velocity. That is what I am saying. Is it okay?
Yes, sir.
Understand, Amma? Everybody clear, Amma?
Yes, sir.
Now, you see that we know the initial velocity, we know the final velocity, and we know the distance, as well as change in velocity. We used to call something term. Anybody can tell me? Change in velocity we used to known as Akilan?
Acceleration.
Acceleration. Change in velocity. We used to call it as what, guys? Change in velocity is known as acceleration. So we know acceleration. Can you give me the relationship between initial velocity, final velocity, distance, and acceleration? From which one? From all of you. Third equation of motion. What is the equation? I want to know. Third equation of motion.
2as is equal to v squared minus u
Yes,
squared.
2as is equals to v square minus u square. From that, can you tell me the distance? What do you mean by the distance? Distance is equals to firstly v square minus u square divided by
2a.
2a. This 2a is in multiplication. Will come this side, will become division. Till here, any doubt? Anybody? Yes, please.
Yes, sir.
Any doubt, anyone can ask me. Now, we all knows the work done formula. What is the work done formula? Fastly. Work done is equals to. Work done is equals to formula. We know. Yes, please. Now tell me. Now Omar is traveling with some initial velocity. I pushed him from the backside so that he attains some other velocity after traveling some distance. Now, what is the work done by me? What is the work done by me? Work done is equals to what is the formula? Everybody? Force into displacement.
Displacement.
Now, in place of F, what I can write? Now, work done W is equals to, what is the F is equals to all of you? Mass into acceleration.
Acceleration.
Distance is equals to what is the formula? Distance is equals to V
v
square
squared
V square
minus u squared divided by 2a.
by 2a. Any doubt? Anyone?
No,
Now,
sir.
something will get cancelled. Let me see what will get cancelled. Fastly.
Acceleration.
Acceleration will get cancelled. So it will turns into m into v square minus u square divided by 2. Is it right or wrong?
Yes, sir.
Now, by 2 I will bring front. So it will turns into what? You also tell me. Mr. Nimish, Mr. Gokul.
1 by 2
1 by
into mass.
I will take it as a 1 by 2 into mass into v square minus u square. Now mathematics, a into b minus c. How I can write? Fastly. A into b, ab
AB
minus
minus
a
AC.
into c, ac. Is it right or wrong? Mr. Johan? Gokul, that is what. So according to that, now Mr. Johan will say, what is the answer? Tell me fastly. Everybody. So 1 by 2 into, fastly tell me guys, what will happen? 1 by 2
1 by 2 into m into
v
v
square.
square
What will
plus v
happen? This 1
square
by 2 is also for
minus
everything. Understanding? 1 by 2 m into v square. What will happen? Fastly.
v squared minus
M
mu squared.
minus 1 by 2 into m into u square. Is it right or wrong?
Yes, sir.
Yes, everybody. So if you are getting confusing like this, you see 1 by 2 as a AB. So AB into now C minus D, like you take. So what will happen? AB into C, ABC minus AB into D, ABD. Is it right or wrong, guys? Yes, please.
Yes, sir.
So we will get work done is equals to half into mv square minus half into mu square. Okay. So this is only called as work energy theorem. What is to call? Work energy theorem. Is it okay, everybody? Now, have you noticed it? Of course. What is the kinetic energy formula? What is the kinetic energy formula? Everybody.
Half of mv square.
Kinetic energy equals to half mv square. Here, v means final velocity or initial velocity or just as a velocity. I want to know from
Only velocity.
initial velocity or just a velocity. This v means it is
It's
just
just
a
a
velocity. Understanding? It is not a final velocity. It is not a initial velocity. It's just a what? Harish? It is a
Velocity, sir.
velocity. Understanding? But here you see, this is final velocity, this is initial velocity. So according to that, can you tell me what is the work done means formula? Yes, Mitakshri, Abhiravi, work done is equals to, what is this one? Change in energy. Read the definition. What is the definition? Change in kinetic energy. So what will come? Formula. Final kinetic energy minus
Initial.
initial kinetic energy. Is it okay, everybody? Gokul, this is only called as work done. Please remember that. So that is why we will say, thus, the total work done is equal to, understanding, change in what, guys? Change in its which energy?
Kinetic energy.
So that is one. Clear, everybody? Ask me, Hari Omar, what is your doubt? Ask Omar. So please solve. Understand, Harish? Vakilan?
Sir, can you hear me?
Yes, sir. Yes, Omar.
Sir, can we use algebraic identity in the v square minus u square?
You can use. But
Okay, sir.
you were saying like a square minus b square.
Yes, sir.
Well, that is what. Why we are making more complicated? We don't need to make more complicated. Just multiply with it. That's all. Over. Correct. Understand, Omar?
Yes, sir.
Have you understand, Amma, everybody? Clear, Mitakshri? Akilan? Mr.
Yes, sir.
Sanjay? Yeah, please solve it. This is the most important one. Change in kinetic energy. Also, we can apply this formula. As we all know, work done is equals to energy possessed by the body. Yes or no, everybody? Yes, please. So, kinetic energy is equals to final kinetic energy minus initial kinetic energy. So, this K is only called as, what was to call, guys? Change in
Kinetic energy.
kinetic energy. So change in kinetic energy is equals to final kinetic energy of a body minus initial kinetic energy. Is it okay, everybody? Anything doubt? Ask. Clear?
Yes, sir.
So immediately we will solve an example so that you will understand it. So first I'm giving 2 minutes time. Derive everything neatly. Anywhere, any step you having doubt, kindly ask. You have to take neatly the assumptions, all the things. So here you have to remember one thing. Initial velocity of the body is not zero. Understand, Mr. Arun Kailash? Danishkar? Initial, already body is having some velocity. Already a body is having some velocity u. Due to the applied force, the velocity changes to v after traveling certain distance. That is what you have to remember. Okay, Harini? Only one day response. Yesterday responded, later no response. Okay? So that's do it. Solve it, everybody. Completed? Take your time and
Yes,
do.
sir.
Mr. Ashwin Balaji, you understood or not? At least you can say thumbs up something. So I'll understand. Response is very important. Do it fast. Ashwin, understand, Ashwin? Solve it, solve it. Completed with Akshri? Abhirami?
Yes, sir.
Okay. Read out over.
No, sir.
Notes must be right. You are simply attending, sir, I am remembering, I will never accept it. You must make your notes properly from this level. Then only I can expect you will do better in higher classes. So please very careful. Next year you will do well. That is what you have to remember. Make proper notes. All of you must write everything. How neatly I am writing the same way how to write it. You see the present class 10th, how perfectly they will write, Those who are written the classwork, today they are doing very well. Those who are not written the classwork, they are always like you people only. Some of you like you are facing. Your friends also, so many of you are writing notes well. They will definitely do well in next year also. So concentrate on it. Right. First question. Shall we solve one example related to this? Work done. Okay, work energy theorem, everybody. So what is work energy theorem? Work done is equals to change in kinetic energy. That is only called as work energy theorem. That is what you have to remember this formula. Okay. So now write the question. What is the work done? What is the work done? What is the work done? What is the work done in increasing the velocity of a car from 30 kilometer per hour to 60 kilometer per hour. Have you noticed it? Now tell me, what is the initial velocity of the car? Is it 0 or 30? Everybody. 30. So you might be understand. If initial velocity is 0, you must apply the formula kinetic energy equals to half mv square. But initial velocity is not 0. Which formula you should apply? Kinetic energy formula or work energy formula? Work energy theorem.
Work energy formula, sir.
That is what. If the
Sir, but mass is not given, sir.
yes, wait. If the mass of the car is 1,500 kilogram. Understand, Harish? But here,
Yeah.
one more thing you must remember, everybody. What is the thing before going to substitution? You have to take some other thing. What is that, anybody?
It's like
must,
we have to convert to
yeah,
meter per second.
Kilometer per hour to meter per second.
yes, kilometer per hour to meter per second. That is mandatory. You all need.
Into 5.
Yes.
Multiply by 5 by 18. Sir.
Yes. So given, write it neatly. So initial velocity 30 kilometer per hour. One more thing I told you, diagram. So take the car having initial velocity 30 kilometer per hour. After traveling some distance, we don't bother about the distance. So it will reach us to the final velocity. What is the final velocity? All of you. 60 kilometer per hour. Okay, so 30 kilometer per hour means we all know 1 kilometer per hour is equals to how many meter per second, everybody? How many? 5 by 18 meter per second. Is it right or wrong? All of you? No response. That is. So I will say Harini solving 30 into 5 by 18 meter per second. So get cancelled. 2 9s are 2 15s are. Is it okay, everybody? So next, any table?
25 by 4 meter per second.
3 3s are 3 5s are. So which is equals to 25 by 3 meter per second. Is it okay, Harish Jairaj? So that is the initial velocity. So if you want
Yes.
fraction also you can take, or if you want in decimals also you can take. So which you want? 25 by 3, which is equals to how much? 8.33 meter per second. Is it right or wrong? All of you verify it and tell me. Abhirami, day by day going down. No response. Okay, do it fast. Now meeting will end also. Please join fastly. We'll solve one more question and we will solve later. Next, final velocity verified. 60 kilometer.
50 by 3 meter per second.
Which is equals to 60 into 5 by 18 meter per second. So which if you solve, so again 2 9s are 2 30s are, next one, next 3 3s are 3 10s are, next, how much it will come? 50 by 3 meter per second which is equals to 16.67 meter per second. Is it okay, everyone? Yes, please. All of you? Now,
Yes, sir.
mass of the car. What is the mass of the car they have given? M is equals to
1500 kilogram.
kg. Now, what they are asking? Work done. So, work done means what is the theorem we have to apply now here? Work energy theorem. So, W is equals to what is the formula? Fastly, work energy theorem. Half mv square minus half m u square. Understanding? Work energy theorem. So, we have to substitute 1 by 2 into 1500 into velocity square. You take fraction or you take decimal, your choice. But which is your preference? I don't know, your choice. So you choose. So I am putting the decimals 16.67 whole square minus 1 by 2 into 1500 into u square means 8.33 whole square. Okay. So that is what you have to do it. Solve it. Okay. Harish already found the answer. Very good, Harish. Harish Zairaj, I think. Okay. So solve it, everybody now. Meeting is going to end. Please join back. Anyhow, I will get cancelled. 2 ones are 2 750s. Is it right or wrong, guys? Here also 2 ones are 2 750. So that is what I can do it to minimize the calculations. Now all of you do it, everyone. So 750 into 16.67 whole square means 16.67 into 16.67. Do the multiplication and tell me the value.